So, hello everyone. So, we're going to do a laboratory activity 5 which is named as case structure. For the objectives, first is to design an application using LabVIEW, create a case structure, run and simulate the cases of the case structures. So, for the first step, open your LabVIEW, then click Create Project. Click Blank Project, then Finish. Create Project. Blank Project, then Finish. Click the new on the upper left corner. And then simply on the VI folder, click blank VI. Okay. Two window will appear. And then we just side by side. To create the case structure, right click on the left panel and click structures, then click case structure. Right click structures and case structure. To use your case structure, you need to create a responsive control on the front panel. Right click on the right panel and click Boolean, then click push button. Boolean push button. You will see that it will automatically creates an boolean function there. Function true creates an true or false cases. So we will put this outside and we will simply connect the dialog and insert one button dialog and then create constant. You press the button. On the false section, right click the case structure dialog and user interface, then click one button and create constant and type press the button first. So for the false, we can simply copy this, then paste it here, and then change this to press the button first. So there. Next step, run the program by click the arrow symbol. The message will be shown if you not pressed the button before running it. So basically what case structure does is, for example false, press the button first. So we press the button and then after we run, you press the button. So that's the case structure. It has two structures, either true or false, either on or off. So for this step, we will just make a block diagram and front panel. So basically we'll just copy this. So for the, let me show you, for the front panel, change this to temperature, change this to 200 as the highest, then thermometer, we need a thermometer there, and we need a indicator. So right click this, appearance, then display, we'll put it below. We also need a numeric control again for the milliseconds to it, then we just make it smaller. We need a while loop. For the stop, we need a control. We need a this one. Connect that. And then for the temperature, divide. So there. We're done with the front panel and block diagram. So this is the final front panel and block diagram. So now we can proceed to the next steps. So for the first step, 12.1, change the button into a numeric value. Screenshot the block diagram and front panel. So basically, change the button. 12.1 says change the button into a numeric values. So these are the numeric value. So for example, if we run this there, For example, a 32 Fahrenheit is equivalent to 0 Celsius. So for the next question, modify the program to show the Kelvin value and add an additional button. Screenshot the block diagram. So for the 12.2, modify the program to show the Kelvin value and add an additional button. So we will be needing a case structure. So let me show you. So let's see what this do. So for example, if 0 here, the value that will be input here will just copy in thermometer, but if we input 1 here, which is this functions, for example a 32 Fahrenheit will be converted to a 0 Celsius. Then to stop. So next for the Kelvin, just make this bigger. We're going to need a case structure again. And we will copy this one and paste it here. We will add a function which will convert to Kelvin. We create a constant of 273.15 because that's the formula. Then we will need a control for this one. Then connect this one and this one to here. And for the false, we'll just connect this here. And then what this do, run. So for example 0, it just copies the temperature to thermometer since it doesn't have any boolean functions. And when it is true, for example it's 273.15, it means this is a Fahrenheit to Kelvin. So basically if this is on, it performs a Fahrenheit to Kelvin there, as you can see. But if we change this to 1, it performs a Fahrenheit to Celsius. So we just put a label. Let's test it again. 0. Oh, it's interchange. F2 Kelvin, F2 Fahrenheit to Celsius. Let's run. If it's 0, when the input is 32 Fahrenheit, it is 273.15 Kelvin. And if the numeric control input is 1, it's Fahrenheit to Celsius. So for the 12.3, create a warning sign if the temperature goes up at least 60 degrees Fahrenheit. So to create this, we need more space. Then we add greater article, then we add temperature to X and create constant 60. Then we create an indicator which will light up when it is greater than 50. temperature. So if we run, there you can see that the temperature, if 59, it's not the LED is off, but if we input 60, it will turn on. So basically 60 above, 60 Fahrenheit above, it will stay on, but 60 below will stay, 59 below will stay, the LED will stay off. So for 12.4, create a double case structure to show if it is hot, normal, and cold. Hot is equal to 343.15 Kelvin, and normal is equal to 342.15, this is Kelvin, and cold is equal to 322.15 Kelvin below. So in order, let me show you how to do this. So we need this space, and we need a case structure again. Put it here. So we need a control. And we need to have one output of that here. Then we need this part breaker. This and so we need the need constant 343.15. For the equal, it's 342.15. And for the speed, it's 3. Then we have this here. This. And we need to put indicators for each outputs. Hot, hot, hot. So we try to run this. We fix this first. So here we try to run the program. So this should be always on, since it should be true. So if the value is 343.15 Kelvin above, the LED hot should be on, and if the Kelvin is 322.15 below, this one should be on, since it indicates that it is cold. And if the Kelvin is equal to 342.15, which is normal LED is on, and it's indicate a normal temperature of Kelvin. So that's it. We're done with laboratory activity 5. Thank you for listening.